about topic 2.7, facilitated diffusion. So what will we be learning today? For today's video, we're going to look at why are membrane proteins required for diffusion of certain molecules? How do large quantities of water move across the membrane? How do membranes become polarized? What molecules are necessary for active transport? When is metabolic energy, such as ATP, needed for transport? And how does the sodium-potassium pump contribute to membrane potential? So let's dive in. Membrane proteins are necessary for facilitated diffusion. Facilitated diffusion is this movement of molecules from a high concentration to a low concentration through transport proteins. Large and small polar molecules need channel or carrier proteins that get across the membrane. Water in large quantities pass through aquaporons. Charged ions, including sodium and potassium, require channel proteins. For active transport moves molecules and or ions against their concentration gradient from a low concentration to a high concentration. They rely on carrier proteins called pumps. They need metabolic energy, such as ATP, and they help establish and maintain concentration gradients. Co-transport is a secondary active transport that uses energy from an electrochemical gradient to transport two different ions across the membrane through a protein. There are two types of co-transport. The first is symport. It is where two different ions are transported in the same direction, as shown in the illustration. The other type is antiport, where two different ions are transported in opposite directions. So membranes may become polarized by the movement of ions, which help in the formation of gradients. One type of gradient is an electrochemical gradient, which relies on membrane potential, which is an electrical potential difference across a membrane. Membranes may become polarized by the movement of ions across the membrane. As shown in the illustration, the sodium channels open up, they diffuse across, and the potassium flows the other way due to the membrane potential and concentration gradient established across the membrane. So let's look at an example. For the sodium-potassium pump, it helps contributes to the maintenance of the membrane potential. How does it do that? Well, it takes three sodiums and pumps them against their concentration gradient, as shown in the picture, to establish a concentration gradient of sodium. And then it also pumps two potassium ions the other direction to create a concentration gradient for potassium, but it's also creating membrane potential. So let's practice. For today's practice, the skill focus is argumentation. You're going to predict the causes or effects of a change in or disruptions to one or more components in a biological system based on a visual representation of a biological concept, process, or model. So let's practice. What I would like you to do now is pause your video, read the question, formulate your answer, and then push play again. Welcome back. For this question, you were looking if ADH secretion is inhibited, which of the following would initially result? And your answer should have been D. The person would produce greater amounts of dilute urine. So what should you take away from this lesson today? First, membrane proteins are required for facilitated diffusion of charged and large polar molecules through a membrane. Large quantities of water pass through aquaporons. Membranes may become polarized by the movement of ions across the membrane. Membrane proteins are necessary for active transport, along with metabolic energy, such as ATP, to help establish and maintain a concentration gradient. And finally, the sodium-potassium pump helps contribute to the maintenance of that membrane potential. I hope this video was helpful today. Until next time, thank you.